Hey, welcome back to your favorite trigonometry class. This is what we're going to take a look at, properties of the trig functions. Here's our objectives. Let's start out with discussing the domain range of the trig functions. Now, we're going to kind of this is going to be very brief because we discuss more about the domain and range as we create the functions and graph these functions, okay? But as a reminder here, if you remember on the unit circle, our sine value is the y, our cosine is the x value, the tangent's the sine over the cosine, the cosecant's just the reciprocal of the sine, right? So it's 1 over sine, which of course is the y. Secant's the reciprocal of the cosine, so 1 over the cosine, and cotangent's cosine over sine. Now, the domain of the sine function is a set of all real numbers. In other words, if you actually created it, you said f of x is sine of x, or f of theta, we're usually using theta here. We say, well, the domain, what can I plug in? I can let that angle be anything I want, right? I can rotate this much, or maybe I can rotate that much. I can keep rotating that much. I can let theta be anything we want. So the sine domain is a set of real numbers. Same thing as the domain of the cosine is a set of real numbers. Now the output, once you take the sine value, wherever you're at, right, the sine of a value, that's your y value, right? The sine of an input. So once that output then is going to be between, 1, right? That's the highest value, and -1, that's your lowest value. So your range on that's going to be between -1 and 1. The cosine, on the other hand, the x values are going to be between -1 and 1 once you find wherever the cosine is, right? That x value is always going to be a minimum -1, maximum of 1. So there's your range on that. Again, we'll get more into those later in the course. All right, let's get into some talking some more about periodic functions, okay? So the sine, this is saying the sine of theta, sine of an angle plus 2 pi k, whatever k is, like let's let k be 1. So the sine of theta plus 2 pi times 1. So the sine of theta plus 2 pi. This is saying, well, that's the same as sine of theta. Well, of course it is, because this is just one revolution around. So it's whatever that value is. So like, let me give you an example. Like, let's say we had pi 6 plus 2 pi. So this is saying, well, if I go around once, right, let me find this, because this total angle, this is the same thing as pi 6 plus 12 pi 6. So what we're doing is this is the sine of 13 pi 6, right? In other words, we're around once plus pi 6 more. We're around once plus pi 6 more. There's 13 pi 6. Well, that's the exact sine value, right? The sine of 13 pi 6 is the exact same thing as if I just rotated pi 6 amount, right? Both of them have a sine value of a half, right? So with the sine and the cosine, your period there is 2 pi, okay? And this definition here is just saying, hey, if you've got a function that's periodic, if there's some number p such that this property holds, right? It's periodic. So again, with the sine and the cosine, your period is 2 pi, whereas with the tangent, your period is actually only pi, right? Like, let me give you an example. The tangent of pi 6, right there. The tangent of pi 6 is sine over cosine. So we got 1 over root 3 or root 3 over 3. Now the period of the tangent is pi. It's not 2 pi. So if I go another pi around, so in other words, this whole rotation here, pi plus pi 6 is 7 pi 6. So if I go an extra 180 degrees to right here, now I'm at this 7 pi 6 point. Notice this tangent 7 pi 6, sine over cosine, negative over a negative is a positive. It's the same thing. So the period of the tangent is pi. Okay, period of the sine and the cosine is 2 pi. Period of the tangent, just pi. And then their reciprocals. The reciprocal of the sine has a period of 2 pi. Reciprocal cosine, secant, has a period of 2 pi. The reciprocal of the tangent, cotangent, has a period of pi. Again, we're going to revisit those. That'll be we'll get more into depth as we graph these functions. So, but let's do some applications here and find some exact values. Let's find the sine of 17 pi fourths. So I'm going to draw this. I always like to draw it, and I say, well, 17 pi fourths, that's more than 2 pi. Here's 2 pi, right? 8 pi fourths, I'm going to put 2 pi in as with a denominator of 4. So 8 pi fourths is 2 pi. Well, I can go another time around. That's 16 pi fourths. How many more pi fourths do I need? I need one more pi fourths to be 17 pi fourths. So this is going around 1 revolution, 2 revolutions, plus pi fourths. 1 time around, 2 times around, pi fourths around again. Where am I at? I'm at the same spot as pi fourths is. It's the exact same thing as the sine of pi fourths. What's the sine of pi fourths? It's the y value, root 2 over 2. Let's do that next one, cosine 5 pi. So I'm like, well, cosine, that's more than 2 pi. Could I go around again? You bet. 2 pi, there's 4 pi. How many more pi's I need? One more pi. So I'm around twice. 1, 2, plus pi. So I'm right here at this point, negative 1, 0. What's the cosine there? So the cosine of 5 pi is the exact same thing as the cosine of pi. It's negative 1. Let's do that last one there, tangent 5 pi fourths. Tangent 5 pi fourths. Get rid of these real quick. So now 8 pi fourths is more than 5 pi fourths, so it's not once around. This is only one timer. I'm sorry, this is only pi around. 4 pi fourths plus pi fourths. So it's pi plus pi fourths. I'm like right there, that's where my 5 pi fourths is at. So you find your spot, negative root 2 over 2, negative root 2 over 2. And you say, what's the tangent of 5 pi fourths? Well, it's the sine over the cosine. So we got 1 on that, okay? All right, so the signs of the trig function. So here, some people like to say this is how they remember who's positive. All students take calculus. So all of them are positive, at least in terms of sine and cosine. So sine is positive, right? Because the sine is the y value. The y value, right, are going to be positive in which quadrants? This is quadrant 1, this is quadrant 2, quadrant 3, quadrant 4. Okay. So the y values are going to be positive in 1 and 2, right? That's where your y values are positive. So you know these are positive, 1 and 2. The cosine, the x's, where's the x's positive? Positive x? 1, and down there in 4. You know the cosine's positive down here. Now, if both the sine and the cosine are positive, then you know the tangent's positive. So that's why we say all of them are positive in the first quadrant, all, right? Now, in quadrant 2 and 3, your cosines are negative. That's where your x's are negative, right? Your x's are going to be negative in quadrants 2 and quadrants 3. Now, your tangent's positive in quadrant 3 because the sine and the cosine are negative. So a negative over a negative is a positive. So you know the tangent is positive in quadrant 3. All right, if the sine is negative, cosine's positive, name the quadrant in which the angle lies. Let me start with the cosine positive. Again, if I have a cosine, if my x is positive, that means I'm either here or I am here. If cosine or my x is positive. Now, as far as my sine being negative, where's my y value negative? This is where my y value is negative, right? In 3 or 4. So where do they both occur? Where is my y negative and my x positive? Right there, quadrant 4. So it's got to be quadrant 4. All right, I introduced these last time, or maybe it's the first section there, the reciprocal identities. Remember, the reciprocal, the sine is the cosine. So as the cosecant, the cosecant, so 1 over sine. The secant's reciprocal to cosine. Cotangent's reciprocal to tangent. Tangent's defined as sine over cosine. Cotangent just flips that around. Those are your quotient identities. Very fundamental identities in trigonometry. All right, let's do some more problems here. Given that the sine of theta is root 2 over 2 and the cosine is 5 root 2 over 2, first of all, notice that the cosine and the sine are positive. So I'm going to draw this, or I could draw this, right, into, I know this is in quadrant 1, right? This is in quadrant 1. They're both positive. But all we have to do here is find the exact values of the 4 remaining trig functions using the identities. Well, the quotient identity says, well, let me write them all first. What we got? This was given. Cosine's given. So the rest of these are no problem. We've been given so much because the tangent's the sine over the cosine. So that's root 2 over 2 over 5 root 2 over 2. So it looks like we got 1/5 for our tangent. Who's the reciprocal of the sine? Cosecant. So I got 2 over root 2. Now I rationalize that. So I got 2 root 2 over 2. I got root 2. Who's the reciprocal of the cosine? Secant. So I got 2 over 5 root 2, and I got to rationalize that. So I got 2 root 2 over 5 times a regular old 2. 2's cancel. I got root 2 over 5. And finally, who's the reciprocal of the tangent? Cotangent. So instead of 1/5, I got 5 over 1, or 5. All right, the Pythagorean identities. So Pythagorean identities say this is sine squared plus cosine squared equals 1. And by the way, that, if you think about your unit circle for a minute, where our radius is 1. This is our x, this is our x comma y, right? In other words, I'm over x amount, I'm up y amount if I draw that triangle. And we know for a right triangle, and this radius is 1, we know x squared plus y squared is 1. And with our unit circle, we know the x value is our cosine. That's the cosine of theta for that theta rotation. Our y is our sine. So cosine squared theta plus sine squared theta is 1. And you usually write a sine squared first. That's just kind of tradition. Yeah, I call that, that's where that comes from. I call that the money formula. You got to memorize this. You will see this all the time. All the time. Okay? This is your baby. Don't forget that. Sine squared plus cosine squared equals 1. Now, the other two are important, but frankly, you can derive them very easily. If you know that the sine squared plus cosine squared equals 1, what if you just went like this and divided that by cosine squared? Everybody by cosine squared. So this side by cosine squared, that side by cosine squared. Now you got tangent squared, because sine over cosine is a tangent, plus cosine squared over cosine squared is 1. 1 over cosine squared is the secant squared. Look at that. Boom, that's right there, right? Now what if you took that sine squared plus cosine squared equals 1, and instead took that money formula, and this time you divided by sine squared, both sides. Now you got 1 plus cotangent squared equals what's 1 over sine? Cosecant. Okay, so there's that one. All right, so they all stem. That's your Pythagorean identity. That's your money formula. I like to call that thing. Do not forget the money formula. Okay, here's those fundamental identities. Fundamental meaning these are your babies. We're going to see these a lot in this course. All right. Find the exact value of each expression. You guys know I love my blue. I got to go back to my blue here. Do not use a calculator. So we're going to use those fundamental identities that we just learned about. So what I like to do when I'm doing these is, I've got cotangent of 40 here and cosecant. I put everything in terms of sine and cosine. So I'm like, well, I know cotangent is cosine over sine. I know cosecant's 1 over the sine. I know secant's 1 over cosine. But then I got a complex fraction here, so I gotta clean this thing up. So I'm gonna multiply it by cosine 40 degrees. One both top and bottom, right? So I got cosine of 40 degrees times 1 over 1 times sine of 40. So I got cosine 40 over sine 40. Right here. In other words, cotangent of 40 degrees minus cotangent of 40 degrees. It's like 3 minus 3. What do I have? 0. Let's do this next one here. I got 1 over cosecant squared. Well, cosecant's the reciprocal of the sine. So this is like 1 over sine squared pi 16ths. So once I clean that up, right, when I divide by a fraction, I got keep change flip. So multiply by sine squared over top and bottom here. So I got sine squared pi 16ths plus cosine squared pi 16ths. So what's sine squared theta plus cosine squared theta? Right, as long as these are the same thing, which they are, they're both pi 16ths. This is 1. Sine squared pi 16ths plus cosine squared pi 16ths, 1. 1 it is. Alright, I'm actually going to stop that here. I'm going to start this on the next video. Thanks for listening. See you next time.